The speed time graph is very similar to your velocity time graph. The only difference is that speed is a scalar, so you can see that it only involves the positive dimension. Okay, you can look at the graph. There's nothing below the zero. Okay, if you look at a velocity time graph, what happens is that you will have negative numbers. So actually the y-axis in this case will have negative regions. Okay, let's interpret this diagram. You have an object, a stone, that falls vertically. So it is a one-dimensional question because it falls vertically. Okay, so what happened is that this is the start, t equals to 0, and you can see that when t equals to 0, your speed is 0. So meaning that this guy fall from rest. Okay, so what happened is that when this rock fall, it actually hits a rubber mat at the bottom and rebound. So at first it is having v equals to 0, and then it is falling downwards. Just before it reaches the mat, it will reach its maximum speed. And then after that, the rock will actually undergo a certain rebound, and then it will go up, and then it will reach the maximum height, right, of the rebound. Yeah, so you can see that the direction of motion at first is down, and then after that it become upward. So there's a change of direction. But if you look at this graph, because the y-axis is speed, you would not have the positive negative. But if it is a velocity graph, then you would have positive velocity and negative velocity because of the change in direction. One is going down, it could be positive velocity, and then after that it goes up, it could be negative velocity. Okay, so let's look at the thing. So you can see that from 0 to 1, the speed of the rock is rising, it is becoming larger, and that is what you observe every day. If you drop something from the 10th floor, it will speed up all the way until it crashes into the ground. So you can see that the rock is actually accelerating, it is speeding up, right? And then upon rebound, right, so you can see that at this point, velocity comes to 0. So most likely this is the point whereby the rock U-turns, right? So when the rock U-turns, the velocity has to be 0. And then you can see that right after the U-turn, the rock actually has a very high speed. It is like when you throw something up, the moment it leaves your hand, it is at maximum speed. Then after that, gravity will actually slow down the rock or whatever object that you throw up, and then there will be a point whereby it reaches the maximum height. So when it reaches maximum height, you can see that the velocity has become 0 again, right? So what happens is that when you first throw the rock, it is at a very high speed. Then after that, gravity will kick in, it will slow down the object until down here, v is 0. So you notice that v equals to 0 actually indicate many things. V equals to 0 indicate that the object has reached maximum height. V equals to 0 also indicate that there is a U-turn, there's a change of direction. So you should know all this. So this point, whereby it reaches maximum height, it will be your D, which is this point. Yeah. B and C would be the point, this is right before impact, this is after impact. And then of course A will be the point whereby it just starts. So this is what we mean by interpreting the graph. So this is just a rough understanding. Now we need to put in the numbers. So since now we know that B is right before impact, you can actually read the speed is actually 10. So now we know that this maximum V downward, this is before impact, your speed, or I just use the word V lah, it's easier. Your V is actually equals to 10 meter per second, and it is moving downwards because it's before impact, right? And then you look at C. C is after impact, so I can now fill in here. So for your C, it is after impact. yeah, and it has a velocity of 8, right? And it is going up, yeah, and then of course D you will have velocity of 0, yeah. So now I have all this data. I can now look at the rest of the question and see what do the questions want. So using information from figure 1, I have to describe the motion between A and B. So when we describe motion, we need to involve basically a noun plus the appropriate adjective. So what is the noun? The noun could be velocity or it could be acceleration, these two. What is adjectives? Well, adjectives could be increasing, it could be decreasing, it could be constant, it could be 0. Yeah, so there are a few adjectives for you to pick from. So let's look at A to B. So down here I can see that A to B, obviously if I want to describe it in terms of speed, what can I say about the speed? Well, the speed is increasing, right? It is getting bigger. Correct or not? Yeah. And how about the acceleration? The acceleration refers to the gradient, right? So acceleration basically is given by the gradient of your velocity time graph, and in this case it will be a speed time graph. Yeah, so what is the gradient like between A and B? The gradient here is constant, so gradient is acceleration. I just need to do a substitution. Gradient is constant, so therefore acceleration is constant. So that's it. Now if you are in my class, then whenever we talk about speed and I say that it is increasing, I need to actually also tell the examiner what kind of increase is there. Is this increment constant or is this increment changing? So how do I tell? So can you see this part? From 0 to 0.5, I can see that it increased by this amount. This is the increment in the speed. From 0.5 to 10, you can also see that this is the increment. So I want to tell whether this increment, is it constant increment or is it changing kind of increment. So obviously you can see down here the number of square covers, and the number of square covered by this is the same, right? I'm referring to this increment and this increment, they are the same. So we can say that the increment, the speed increases at a constant rate. So when we are talking about speed or velocity, and if the thing is increasing or decreasing, usually we need to supplement it with one more adjective. But for acceleration, there's only one adjective that follows. It's either constant, rising or dropping, increasing or decreasing, or 0. Okay, but for velocity of speed, you will need two adjectives. Okay, increasing constantly, increasing at an increasing rate, or something like that. Yeah, so we will see. Okay, in part B, state how this figure actually shows that the distance between AB is larger than CD. So another thing about VT graph is that you will know that the distance or the displacement is given by the area under the line or under the graph, depending on your textbook. So if I look at this, between AB, I can see that this area between AB, right? AB, B is until 1, huh? This is B. Okay, AB is definitely larger than the distance covered by CD. C is here, so I'm talking about this triangle, right? So how do I face it? Well, very easy, right? The area under AB is larger than CD. It is just one mark and there's only one answer line, so just give him one liner answer. Yeah. Okay, then after that you need to explain the difference between speed and velocity. The easiest way to explain is, of course, speed is a scalar, but velocity is a vector. You notice that this question is a 2-mark question and it has two answer lines. So the examiner is telling you, can you please elaborate what is the meaning, what is the difference between a scalar versus a vector. So the second line I will elaborate it and say that hence speed does not indicate any direction, but velocity does. Okay, so this is how you attempt Cambridge question. You look at the number of marks given and you look at the number of answer line given to determine how detailed you need to give your answer. Okay, it is not always good to give a one chunk of answer because then you will be using up additional time. Yeah, so the last question is about the change in speed and the change in velocity. So what is change? Okay, this change happened between B and C, right? So technically, whenever we are talking about change, we will take the later time minus the earlier time. For example, if I ask you, what is your change in height between 2000 year 2000 and the year 2020, how would you calculate this change in height? Well, you will take your 2020 height, which is your current height, minus the year 2000 height, right, which is your previous height. So you will take something that is new minus something that is old, right? That is the meaning of change in terms of mathematics. So how do you calculate this? Well, very simple. You just need to take your speed in C or B minus the speed in C or B. Which one is new, which one is old? So if you look at the graph, C actually happens after B, right? So C is new and B is old, right? So therefore this one, C is new, B is old. So we will do that. So speed in C is 8. Speed in B is 10, right? So your answer over here will be minus 2 meter per second. So the change in speed is just 8 minus 10 equals to minus 2. How about change in velocity? Now this is tricky unless you understand. So down here, I want you to look at this thing, because this thing, I am interpreting it in terms of velocity, right? So B happens where I erase this pink color thing first. So B is happening here, C is happening here. Can you see that the direction is different? So depending on your direction, if you decided that, okay, I want to take downwards as positive, then this means that my V is equals to 10 because downward is positive. But it means that your V as C is actually equals to negative 8 meter per second, because downward is positive, that means upwards would be negative. So that's why. So now if you put it here, you will take V at C minus the V at B. So V at C equals to minus 8, right? Minus V at B, positive 10. So it will become minus 18. So this will become minus 18. Can this one, let's put it nicely. This will become minus 2. Yeah. This one will be speed. Let's write it properly. At C minus speed at B. Speed is always positive. So that's how you get it. Sorry. This one should be 8. Okay.